crickets.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented is brought to you by Kobaton, empowering mobile developers. Kobaton allows you to test your mobile app on real devices. Now, this means that Kobaton is a mobile device cloud platform. They provide you with access to real devices so that you can test on the Android devices that you want and when you need them. This allows you to identify issues faster because you're testing on those exact devices. Furthermore, they also provide you with an automatically generated activity log that helps you identify and resolve your issues more quickly. You can test the way that you want. So this is a kind of a cool thing too. You can run your tests manually or you can run them through an automated fashion with some type of script. So if you want to connect it up to your CI server, go ahead. Or if you just kind of want to run a few tests manually, that's also an option. Monthly plans start as low as $10 a month. There's no annual commitment required and users can cancel at any time. Visit kobaton.com/fragmented to start your free 15-day trial and see for yourself.
In this episode of Fragmented, our friend in RxJava paragon of the Android world, Dan Lew, returns for a record 3.5 time. We've been using RxJava over the years now and have even talked to Dan about it in previous episodes. But how has our understanding of Rx use in Android changed over the years? We know some of the super standard use cases for RxJava, but the important question to be asking these days is, when are the times we shouldn't be using RxJava? Are we overcomplicating our code by shoehorning it in different places? Concepts like functional programming and reactive state management have actually picked up steam again. How has this influenced our RxJava use? Are these proper use cases? Listen on to find out more.
Okay, Kaushik, so I'm excited for today's show because you kind of set it up for us, and it's talking about something that we're both very passionate about.
Yes, indeed. So RxJava is something that we've been doing for some time at this point, right?
Mm-hmm.
And
yes.
We thought it'd be nice to maybe, assess the state of the union, so to speak, see how things are going in RxJava land. And we thought it would be additionally interesting if we got someone who knows a thing or two about RxJava to talk with us about this. Definitely.
And I think let's not even wait any longer. Dan Lew, welcome back to the show. I think you're the first third-time guest. So welcome to the show again, Dan.
Welcome.
Thanks for having me back. Hello, everyone.
Yeah, so Kaushik, as you said, we've been discussing off air many times now about various different things about Rx and kind of things that we've run into over the years that we've been using it. We've talked with Dan, we've talked with Jake, we've talked with a whole bunch of people regarding Rx, and it just seems pertinent that we would get someone who's very active in the community and has a lot of good tips and has written a lot of really good blog posts, and that would be you, Dan. So again, thanks for coming on the show. Kaushik, what's some of the things that kind of perturbed you or kind of got you thinking about Rx to kind of get this conversation kicked off with, Dan?
Yeah, so it actually started maybe during I.O., I think, if that was right.
Mm-hmm.
Me and Dan were hanging out, waiting in a line or something, and then Dan also mentioned something along the same lines where my approach to Rx has changed and it's evolved over time, and I thought that was fascinating because I have felt a very similar thing, but I imagine my experience is very different from yours. So I thought this would be pretty cool. So maybe you can kick us off there. Can you talk about what got you into RxJava and maybe how that has changed, or maybe some things that have solidified? That would be a good kickoff point for us.
Sure. So yeah, like you were saying, I feel like my maturity level with RxJava has increased over the years. Because when I first got into Rx, I was pretty much pushed into it by coworkers, and none of us really fully understood what it was about or what its purpose was. We just saw some cool features that we kind of latched onto. So, for example, one of the first great features that we latched onto was its ability to do threading fairly easily.
Yeah.
So it became an instant replacement for async task. Retrofit provided an interface for it, which was great. And so, and all these networker calls, which previously were kind of this complex mishmash, possibly of multiple async tasks.
Nested callbacks.
Yeah, it became a lot simpler with RxJava. And so that was like one of the first things that we used it for. But I think in my immaturity, I didn't realize that like the concurrency support is really just a single feature of RxJava. It's not like the full purpose of Rx.
Can you elaborate a little on that?
Yeah, it's like it's something that kind of naturally follows from the pattern that reactive coding creates. Like, because reactive coding is a very asynchronous method of development. It's very event driven, and so threading becomes a natural part that you have to support.
Right.
If you're using it just for threading, though, then really it's like, have you heard of a future? Why don't you just use a future instead?
Yeah, exactly.
And honestly, when I got into Rx, hadn't really heard of futures. That was a huge blind spot in my own knowledge base of Java. And I think that if you're just using RxJava just as a replacement for async task, you're getting a really large framework that you don't really need to cover a small problem. And so that kind of adds to this confusion about like, what is Rx about and what can you do with it?
Got it. And to be fair, though, I think futures came in with Java 7 or 8, right?
I don't really remember, to be honest, but I just know that like in hindsight, that would have made a lot more sense to use something like future if that's all I'm working with.
Yeah, the interesting thing about the async task situation is that, Dan, I think you explained it well, is that you had this async task and you had all these callbacks. And I remember when I first started working with Android, I had a couple of coworkers who were very well versed in concurrency inside of Java. And so we'd have all these crazy countdown latches and all these different callback mechanisms. And so kind of getting rid of that async task and all that crazy mess of complex code was really nice. And then I really felt, as you rightly mentioned, that when Retrofit provided that interface to it, it was almost kind of like this real easy gateway drug to RxJava, because you could get rid of a bunch of that stuff. And it made a real easy entryway for a lot of folks who are new to RxJava. Because for me, when I got in, that was the initial reason why I needed to do it. I needed to make 3 or 4 calls, and how could I chain these together, etc. And doing that in RxJava made it so much easier. And then it wasn't until later on down the road, after I had built a few apps with Rx or done a few things with Rx, where I realized some of the additional benefits. So it kind of seems like it's a downfall that we're using it for just for maybe the concurrency support, but also at the same time, it almost acts as like this gateway, which is another fantastic kind of a double-edged sword here, really.
Yeah, it's true. And there's another part of that gateway that was kind of built into the early retrofit stuff, which is that it kind of proposed very easy error handling.
Totally.
Yes.
Because before you'd end up with 3 or 4 network calls, and you get into callback hell. You have that pyramid of evil, and every time something could fail, you'd have to like make sure to check all your different states and go to the correct next state. And with RxJava, you had this nice thing where it said like, oh, if you call, if anything fails, we'll just call on error, we'll skip to the end, and then it'll be really easy to handle. But it turns out that was like really the wrong way to set things up.
And why is it the wrong way?
Yeah, because so RxJava, reactive coding in general, is all about like streams of data and composing those streams of data. And on error is really just like the try-catch of the reactive world.
Oh.
Right.
So it's not really for data flow. It's more for emergencies. Like something has gone critically wrong with the code, and you can't listen to the stream anymore. It's not even possible. Whereas a normal network error isn't necessarily the end of the world. Like you might be sending off a network request and the network goes down, and that doesn't mean that you want to be able to compose that state, like the fact that you didn't get a response, with like other streams. And it's difficult to then compose those streams together if you are terminating one of the streams entirely.
That makes sense. And again, like I remember I think it's your blog post on error handling or something. And that's the one that made it click for me, where you're like, if on error happens, something has gone terminally wrong, right? Like something is very, very wrong in your stream. So regular error states is actually not as bad. And like, that's like one thing. Can you give us like, would you think this is a right example of like the approach that you were trying to say, where like handling these sort of errors, like network errors, right?
Yeah.
For example, if I had 3 network calls, right? And one of them errored out, you don't want to necessarily lose the results from the other 2 streams, so to speak, right? And so it's on you to maybe manage that state in a way where like the error from one of those calls is okay, but the other two, like you somehow are able to like send that results to the UI. Is it along those lines?
How do you model that kind of situation?
Yeah, so like what modern versions of retrofit do is instead of just delivering successful requests to on next and error and network failures to on error, instead you can have it return a wrapped object, and that wrapped object contains both the success and the error state within it. And that's a lot better when you any state that you can represent, any state that you anticipate coming down the stream should really be represented in the data object that you're passing down the stream. That's how I sum it up.
By modern versions of retrofit, you mean retrofit 2 and above, right?
Yep.
Okay.
Yeah, because the retrofit 1.x implementation was really kind of like experimental and was written with not a full understanding of how RxJava works. And those got much better with RxJava or with retrofit 2.
Kind of building on that example of having a couple of network calls that are kind of chained together. Let's say you have 3. The first 2 succeed, the last one fails, and we're using, retrofit 2 or whatever. What would you say would be, if I'm going to get some success state, would that maybe the success state from the first 2 calls? And at that point, as a developer, I need to determine what I need to do with that success state? Or should I be building an object, almost like a view model, similar like to a view model object, where it contains the error state in it, which almost has like a state value, so I know what state that object is currently in, and then the error stuff could be used for, like you said, the critical path when just something goes absolutely wrong. I'm just trying to connect the pieces for folks that are really, really trying to understand this end to end.
Yeah, I mean, I think any particular error state that you anticipate happening, possibly, so like a network request failing, or maybe you had some auth that failed or something like that.
Okay.
Or an internal server error, all of that stuff should be like represented in the actual on next call. It should just be some wrapped class that can represent those error states.
Okay, excellent. And then if you get that on error call back, it's just one of those things like, oh, whoops, we divided by 0 or something crazy like that.
Yeah, on error should be reserved for something that's critically messed up.
Okay.
And I guess like as we go into the show, we'll probably touch through this again. But like, that's also like a theme that's been coming up recently with RxJava, right? Like how you manage reactive state, so to speak. And a lot of that goes into like these things. But I guess we'll get into that shortly. What's the other thing that you feel like was the thing that got you hooked onto RxJava pretty quickly?
Yeah, the third thing, so when I started learning about RxJava, I also had a bunch of programmers who were really into Haskell. And they were teaching me about functional programming. And RxJava and reactive code in general uses all these functional operators. And when you first are introduced to functional programming, it's this brilliant, amazing thing where it's like, oh, it's this like stateless programming. You've got these pure functions where the outputs match the inputs. And it's so much easier to work with. And so then in functional programming, it provides all these operators that you wouldn't have normally in code, like filtering and sorting and stuff like that, where you can just chain these calls together. It's nice composable little calls, and like you can manipulate your data that way.
Mm-hmm.
And so people thought this was brilliant, and they're like, let's use it everywhere. And it very quickly makes code complicated, because the reason RxJava has all these operators is because you're dealing with an asynchronous flow of data. And you need to be able to handle events as they come in. But if you already have all the data present, if you're in like a synchronous place, then like you don't have to go to this level of using the RxJava's Stream API version, essentially. Like it just makes the code really weird and complicated.
That makes sense.
I like Kotlin a lot because Kotlin introduces a lot of those operators for synchronous collections, which is much simpler. But anyways, the end result of like going kind of overboard on these functional operators is that you end up with these chains that are like 30, 40 method calls long, and you have to debug one of them, and you're like, all right, call me in like 4 hours when I figure out exactly what every step of this chain is doing. It gets to be like way too complicated with code if you start overloading the operators, basically.
2 quick follow-up questions to what you just said. The first one is, so you said Kotlin has like some interesting sort of operators that's simpler and built in right into the language, right? What are some examples of this?
Well, so like I think one quintessential example is like, suppose you've got an event that spits out like a list of integers, let's say.
Mm-hmm.
And you want to only have like even numbered integers in that list.
Right.
Now, if you're going to use all RxJava based operators, you'd put that in a flat map. You would split the list out into like each individual item, and then you would call filter on that so that you only get the even numbers, and then you would combine it back into a list at the end. And that's very like overwrought, I feel like. Whereas if you're using something like Kotlin, you can just call RxJava's map, and within that map, you can use Kotlin's filter method on the list that you have.
Yeah.
Because that operation of turning an entire known list from all integers into only the even ones is a synchronous operation. Yeah, what RxJava's filter is really for is not that you have like an entire list you're doing at once, but suppose you have like one integer coming at a time and you want to make sure you only have even integers from that. That's when RxJava's filter is really useful. But I think of it as just very asynchronous versus synchronous. Like if you're dealing with data where you know all of the data right at that moment, you can do synchronous code and it can be a lot simpler. But when you're dealing with event-driven asynchronous code, then it becomes a lot simpler. Then RxJava really shines.
Mm-hmm. Oh, I like that. Synchronous versus asynchronous. So you're still using sort of you're using functions or sort of like using functional paradigms, but it isn't necessarily always asynchronous.
Yeah. It's just use the right tool for the right situation, I think. So those are the kind of like the three things that I think people, like my immature approach was, you're using it as a replacement for async task, using it for easy error handling, and kind of going overboard on the functional operators. And the thing that bothers me about all of that was that I didn't understand how far you could really go with RxJava, or how far you could go with reactive programming in general, which is that reactive coding really just lets you loosely couple components. Because you can take the different components in your application, you can define like this component spits out an observable stream of data that other people can hook up to. And it really lets you then separate out your components and create very carefully manage how data flows throughout your application. If you've got a simpler data flow through your application, you can get that through reactive coding, and it's makes things a lot easier. It's sort of hard to explain without like deep examples. Like I just recently posted a blog post that was kind of like an introduction to functional reactive programming, where I tried to step very far away from the actual frameworks themselves and just explain like, why does reactive coding help you loosely couple components in a way that makes sense? And like the example I gave in that was, imagine I've got like a screen in my UI and I'm trying to like show values from the database on the screen. And in the proactive way of coding, what would happen is I would go to, the code would change something in the database, some value would change. And then the database would say, oh, is the UI showing? I should go push this data to the UI, which is like the natural way of coding. But also, if you think about it, is a little insane, because it's like, why does the database care so deeply about the UI? Like, why does it know that the UI even exists? Shouldn't this just be like a dumb store of data? Shouldn't it be the UI who's drawing from the database? And so in the reactive way, instead, what we've got is a UI that says, whenever the database updates, I want to pull those latest database changes to me. That allows the code to be much more loosely coupled, and the flow of data just makes so much more sense then. The database doesn't have to care about the UI, it just has to provide a way for other people to listen to it. And then the UI, that's the one who says, oh, I actually do explicitly care about this piece of data in the database. It hooks into that.
Yeah, when you first learn about the unidirectional data flow, and I first really learned about this when I was working with Rome quite a bit, because I have all these different change listeners and we could push data up from the database. And now there's a bunch of other tools for SQLite and all kinds of other places and other places you can pull data from that are very similar. But once you finally wrap your head around it, it actually makes so much more sense. And like you said, it makes the application a lot easier to work with, because you just change the data and then react to the changes. And just it's simple to follow, and I like it quite a bit. Have you guys done a lot of work, or either one of you done a lot of work in the unidirectional area, or are you both kind of starting off in that area?
I have been pushing us towards that direction. It's very difficult to have a pure unidirectional architecture in Android in particular. Yeah. Right. There's all sorts of weird situations where it's like, well, someone's edit a text, like that change is represented on the screen right now. It doesn't necessarily hit, it's not necessarily going through this big circular flow. I don't know. So it's hard, but what we're doing is we are setting things up to be more single direction flow where we can. So one of the big examples in our code, and the pattern that I'm probably most happy with us using now, is the one I was just describing, where we are listening to the database for changes and then updating the UI ourselves.
Mm-hmm.
And so we've written what we call repositories, where it's basically like, give me a stream of the latest data for this Trello board or something. And then we don't have to care at all about where the data is changing from. It could be from a network request. It could be from the user having changed something, like the user renames the board. It could be from a socket update. And whatever piece of the UI is displaying the board doesn't care at all about who changed it. It's just getting that one data flow from the database to the UI. And then the UI itself sends off, whenever it wants to change something, it sends that off to a third component, which we are right now just calling the modifier. I don't know. This is something I'm working on a little bit. Then that modifier goes and changes the database, and the database changes, and it gets pulled back into the UI. So we have a little bit of that unidirectional architecture, but I can't make any claims that we're pure in any way, shape, or form. We're just trying to make our way towards that.
It feels like the next sort of level in RxJava where people are starting to like evolve these slightly more mature patterns, right? And who knows, maybe 2 years from now, we're like, oh my God, what we did 2 years back was like totally like crazy. So we should be doing this new thing. So who knows? But the evolution is good in either case, right?
Yeah. And it's also supported by the recent Android architecture components, where they've set up this live data, which is very clearly a reactive coding setup. And I really like how they set that up, where live data is sort of like RxLite. It's a very simple version of it. It's good for kind of mass consumption. But if you want to have all those functional operators and whatnot, then you pretty easily upgrade to RxJava. So it's a pattern that I think is just getting more and more popular. And it's especially important when we took the app offline, because we're no longer basically making these direct network requests. So in fact, what we really early on used RxJava for all the time, which was all these network requests using retrofit, we use it so much less for that now. And maybe hopefully someday not at all, because none of the requests are going to be handled directly. It's all going to be indirectly through the UI to the database, which then syncs with the network.
Yeah, that makes a lot of sense, at least like, in terms of like how we've been thinking. So I guess like my next question is, okay, we have like an understanding now of like how we were using Rx. How are you using Rx today, right? Like, so we understand like the approaches of so to speak. What has changed about your thinking and like usage of Rx today?
Yeah, so I mean, the first thing, I think we've covered a lot of this in just terms of like the maturity part, but like for first thing, we just don't use it absolutely everywhere.
You don't say.
To use it to kind of like wedge it into every piece of code, regardless of whether it makes sense or not. Now I focus a lot more on using it to couple components together. So if some class is always dealing with synchronous data and it's completely enclosed, like all that synchronous data is completely encapsulated within the component, like I'm not going to set up a subject or relay or anything like that just to pass data amongst itself.
Say it again, Dan. Say it again.
So, like, if it makes sense, if it's dealing with some event-driven stuff that requires asynchronous code, then maybe sure. But in general, like, just not plastering it everywhere, because it's RxJava is complicated. It adds complexity wherever you use it.
I completely agree. I've dealt with a couple projects recently that are it's Rx everything, Rx everywhere. I feel like we've recreated the event bus problem of being able to trace anything in the entire application. And so I agree. Don't slap it there just because you can.
Yeah. And then also in terms of breaking down complexity is to really take any long chains and try to break it into smaller pieces.
Oh, interesting.
It's extremely tempting to take a long, like to just be like, yeah, I'm going to slap 20 operators on this and it'll work perfectly. But the problem is you have to understand the next person who comes along will have to read every one of those lines of code.
That's a good point.
It's sort of like the equivalent of having like a class where it's got a function and the function just does everything. And you're like, why didn't you break this into like 20 different functions to make it simpler? And you can do the same thing with RxJava. You can use the compose. You can break down the different observables beforehand so that they're kind of well defined. Like this is an observable of all the latest boards. This is an observable of all the latest cards. Like this is this observable of this data. This is observable that says what the connectivity is. And you can see those individual pieces instead of having that all just be inline or something like that. So like treat it like any other programming thing. Break it down so that it's easy to read, kind of a summary of what's happening in the logical flow. And if you know, as a coder, you need to figure out the specifics, you can dive in deeper.
Rx in many ways is like regex. You know, when you're actually writing like the regex, it's like easy to like sort of like find your way to the solution, right? And so with Rx, you're like, oh, I need this, I'm going to transform this stream. But like going back and after the fact looking at it makes it, you know, it is like you rightly said, it is super complicated. Like if someone else has to come and read my Rx code and they see like these 20 chains, it definitely is a little tricky. That being said, one thing that I've found a little tricky, like, you know, with the whole like breaking it into smaller components, at least what I've found is like when I look at like the breakdown of all those operators, in my head, I understand the like what Rx is doing there, right? But the problem with abstracting that and like creating smaller chains, so to speak, is that like is moved away from me, right? And I guess like maybe you're right, maybe like proper naming or something would help with that. But like the problem is like, you know, if it's wrapped around this thing, say, oh, convert to X. I want to know, well, does convert to X like convert it to like maybe an observable of a list or like, you know, and I suppose maybe like with naming that helps. But does that make sense? I feel.
Yeah. It's you have to strike a nice balance. Right, I think Kotlin helps with this because you get extension functions, so you can create these functions which are inline, which look fluent, but they're just private for that particular class that can describe well what is happening to the stream in that step. And I want to go back a second. The regex example is a perfect example where you can write this beautiful regex, but the problem is that it's sort of understanding a regex also involves understanding what sort of input comes to the regex. And I think that's a mistake that's made a lot with RxJava too, is that there's all these weird, complicated set of operators that you have. And the reason you came to that conclusion of those being the correct operators is because you know that the stream of data is going to be something like A, B, C, C, D.
Right.
And then when someone else comes along later, they don't have that context of knowing like, oh, this is the particular, like, there's going to be this particular flow to that data, and that's why the operator is set up this way. So really, it's just about breaking down the complexity so that you don't have to know so well what exactly is coming in, or comment the code if you know that a particular stream is going to have data arrive in a particular order.
I think that's very important to note what you just said right there. There's a lot of folks in the industry who state that the code is the ultimate source of documentation, and there's 100% truth in that statement. However, there are some points where the code, you don't understand the reasoning. And so sometimes you can look at the commit messages, and if there's a good commit message written, it might get you there. But sometimes just even a quick one-line comment of, hey, we're using the combine latest operator here because of X, Y, and Z. It can kind of help you clear that mental fog that might take you 20, 30 minutes of research to figure out why that's there. And that little line of comment can go so far. I'm not saying document everything like crazy, but just know when and where to do it when it's something complex and you have to understand the reasoning behind it.
Yeah.
Especially in cases where, like, you know, it doesn't seem necessarily as intuitive, right? Like, for example, if you have to use a different operator when you would think like another standard operator would work, it helps to, like, you know, at least it helps because it's easy when you're writing the code because you would be burnt by it, right? Like you wrote this thing and you're like, wait, that isn't what I expected. And then like you change the operator. So maybe adding like, those are like sort of helpful indications that where like, oh, maybe I should like add a comment here because, like, you know, this is not something that my colleagues would readily understand.
Yeah, the way I've heard it said before is that the code explains the how and comments are the why.
Mm-hmm. My general rule of thumb is I ask myself on every line of code that I write, that I'm writing, if I come back to this in 6 months from now, will I understand what this is doing, why this is doing it? And if the answer to either one of those questions is no, then I need to clarify the code better and write it in a different manner, or I need to add a comment to specify the why. And I find that the 6 month time frame is perfect for me and usually most other developers because it's just far enough away where you've learned something new. There's been a new library, a new framework. You're starting to adapt your development skills in a different manner than what you did 6 months ago. That code that's 6 months old may not make sense if doesn't properly define the how and the why.
Yeah.
Yeah. I like that. Code is the how, comments is the why.
Yep. So other things we're doing these days, I already explained this earlier, but kind of reacting to state changes. Just
Yes.
that really nice pattern of the database changes and the UI changes in response to it makes it so simple to actually make changes, and it's sort of essential to how our offline support works in the app at all.
Right.
And then likewise, that's sort of like basically a discussion of how do you couple the components of your app together.
Yep.
And really using observables as the method for communicating between components. So one example I've been exploring one case I've been exploring a lot recently are adapters. Like how do you get your data to an adapter, Recyclerview adapter?
Oh, interesting. Tell us more about that.
Yeah, so like the old method, I would just say adapter.setData, and it would bind this list of data to the adapter, and then the adapter would, update all the counts and all that stuff. But to me, it's like, well, wait, it's what the adapter really is doing is observing changes to data. So why don't we pass an adapter an observable?
Interesting.
And then it can subscribe and say, I would like to observe this data source, and that's been very convenient for code. The only downside there is that okay, you have your adapter subscribe to the observable. What happens to the disposable afterwards?
Yeah.
Yes.
Who handles
the
that?
pattern
I was going to follow up with that.
Yeah, the pattern for that then is that we take that disposable and we return that to whoever gives us the observable. And then we say, okay, you've given us permission to listen to this stream of data. Here's also the key to revoke that permission.
Yes.
Basically.
Yes.
That's a good way to look at it. I like that permission example.
And you can take that multiple layers. Like if you're passing that observable multiple ways down, then that disposable can keep going up through parents until you get to a parent who knows what's going on with the life cycle and when that data is no longer valid to be listened to.
So that's a good question I have for you. Do you always pass your disposables up the chain somewhere, or do you kind of handle them right where you create them? Because there's a different. I see a lot of code bases, and a lot of folks will create their disposables, and then they'll try to handle them within the same class. So that means that they'll sometimes introduce some type of lifecycle events inside of a particular class, or I've seen a couple of code bases that pass it up the chain to something that knows about a lifecycle. It could be a presenter or a fragment or an activity. How do you normally do it, or is it a case-by-case basis?
Right now, it's sort of a case-by-case basis. I'm leaning towards passing upwards in most cases, but there is this complexity involved with that. Where I mean, there's sort of two ways to look at it. One is that you can say this object's going to initialize itself. If this object's going to have its own life cycle, but that means that the parent has to call its life cycle methods.
Right,
yeah, exactly.
Right.
And the other is to say this object has no life cycle whatsoever. Therefore, everything should defer to the parent. And really, yeah, it's very case by case which class is doing what there.
True. Yeah, that's yeah. I've been leaning towards like the second approach too. So with the adapter thing, right? If I were to like reword like the API, like in terms of specific APIs for like the adapter example you gave, right?
Mm-hmm.
Adapter.setData is what we're typically used to with like Recyclerviews, and that's like the standard approach. But you mentioned that instead of like actually giving it the data, you would pass in an observable. So if I would rather say like adapter.listen of observable and send in the observable, like that's like an equivalent approach, wouldn't you say?
Yep. Yeah, and then the return value for that would be the disposable.
The disposable, perfect. So that's like a kind of API that works in this case, right? Set data versus like listen.
It's been working well for us.
I do have a question. It talked about the adapter and using observables as a communication mechanism between various different components inside of the application. My question is do you have a heuristic in which you follow of when you should be using the observables for communication? And what I mean by that is I feel like there's kind of like this tipping point of we have the proper amount of using observables, and then we have almost like the other end of the spectrum where we have too much of it and it's over-complicating the code. Do you have any heuristics in which you kind of follow, saying, all right, well, this might be a good place to use it, but over here it just kind of over-complicates things, and we just probably shouldn't apply it? This kind of goes back to the original question of not using Rx everywhere, and if it's synchronous or whatever. But in regards to the communication between the components, is there any heuristic that you have?
Yeah, when I start getting too mad at code, that's my heuristic.
That's a good heuristic.
That's a good one.
I think there are ways to make it simpler though. So for example, like if you have a component that's communicating a bunch of changes, like that doesn't have to be 10 different disposal or 10 different observables that you can subscribe to. It's a lot simpler if it's just a single observable that you subscribe to, and that observable spits out all the different intentions of that component.
Gotcha.
Got it. So like if there's any magic behind like, the way the streams are composed, you sort of like push that behind that single observable, because like honestly, it's a stream of events and that's all it should be, right? Like all the magic can like lie behind that.
And Kotlin's seal classes are great for this.
Right.
Because it allows you to define like, here's like 10 different types that might be returned from this stream, from this particular component. I mean, 10's maybe a little excessive, but like, here's 2 or 3 different things that are going to be returned. And then anyone who's listening to that can very easily separate out the different types of returns from that component.
Right. It adds a little more context to the kind of events that are coming back.
Yep.
Quick follow-up question again to like a previous thing. You said you had this repository pattern and like, from the database you're observing changes. Are you using like any specific library, like one of the new libraries, or have you like sort of like written something on your own?
Sure. It's sort of a mix of the two. So we're using SqlBrite.
Got it.
Definitely for a lot of the SQL. We also, this is kind of a historical thing in our code base. We've been using ORM-Lite for a long time. And it turns out ORM-Lite also has just built into it the ability to listen to changes.
Oh, really?
It was very easy. It was very easy for us to hook into that and create an observable version of that listener.
Dan, you mentioned something earlier about handling the subscriptions and disposables, and how we're talking about passing them up or handling them in place. Now, you recently wrote a blog article about how you felt about those subscriptions and disposables, and maybe about handling them yourself versus using some type of framework to handle them. How are you handling them now versus how you were handling them before, and what's kind of changed? And maybe if you give an overview of your blog post, that would be really fantastic.
What a nice leading question.
Well done.
So when we first got into RxJava, one of the things that really upset us was all of these stupid subscriptions that we had to deal with. Because it just felt like a lot of busy work taking these subscriptions and unsubscribing from them. And we're like, but most of the time, all we want to do is unsubscribe from them when like activity to ondestroy is called.
All I want is my memory to not leak, damn it.
Yes, exactly.
Yeah.
And so at the time, we came up with this really nice solution called Rx that eventually became Rx Lifecycle. It was first part of Rx Android, but then split off as its own thing. And it seems to work really nicely, but just over the years that we've been using it, we've seen cracks in the corner cases. And I think really the biggest problem of it is that its goal is to make life simpler, but what it does is it's so automatic that it actually, like, you kind of have to wrap your head around how it's used, and that ends up making it more complex in the end. So nowadays, I much prefer manually handling my disposables. That is, when I subscribe to something, taking that disposable, figuring out who's going to be calling dispose eventually. And it's tedious, but it's very simple. That you can see exactly what's happening in the code. And over time, I think over the last 3 or 4 years, what I've really grown to value is simplicity over complexity. And even if there's a little more boilerplate, I'll take it because it's so much simpler. It's so much easier to trace through the code exactly what's happening. And it's so much easier to write without having to think about unintended consequences.
I want to pull a quote that, like, and I tweeted this some time back, and I feel it's so valuable. This has like helped me, at least personally, so many times in the past, like in general with my experience with programming, right? You said, yeah, and I'm quoting you here. I much prefer code that is rock solid and never breaks, even if it means writing more boilerplate, right?
Yep.
That is so true. Like like many of my colleagues
That's
also,
like the motto of static typing versus dynamic typing.
True. Yeah. Absolutely. It is so helpful, right? Like sometimes people give boilerplate a bad rep, and like I feel like, boilerplate sometimes is like okay, like there's like that happy balance when like you've gone overboard, and like that balance is usually way further down the line than most people are allowed to presume.
Yep. So, and then the last thing that I've been doing recently with code, and I already mentioned this too earlier, which is that really the emissions, the events that come down streams should really represent the entire state of the situation. that we shouldn't be using on-error and probably not on-complete for most state-like things. You really want to have everything there. It's a little easier with Kotlin because it's much nicer to create these like one-off data classes, which can then, because before the temptation was like, oh, you could say, I've got these two pieces of data I want to pass down. I'll create a pair. Pass that pair down, which is just kind of problematic because you lose all semantic meaning about what's going on. It's nice to have a data class, like just a little one-off data class to say like, this is what this emission represents. And it's only being used in this one particular place.
So I have some more follow up on this because this is a topic that I find like super interesting, and like, you know, this is like these days this comes up pretty often. So for your stream emissions, right? Are you using like a custom object? Because I know Jake gave a talk maybe some time back about like managing reactive state, right? I don't recall what he calls, and like this is again, I alluded to this earlier. Like one of my colleagues wrote like a post, and like we have started to use that where there's like this wrapper object, so to speak, right, which has different states. There's like the loading state, there's like the content where it actually comes down. How has your approach been? Like, have you like sort of like figured out an approach like over at Trello, like where you handle this?
Not really. I mean, it's on a case by case basis. Like if there is a network request that comes back that could possibly have error states, then yeah, we'd have two different states for that. But a lot of code, or I mean, a lot of the times we'll now return optional types.
Oh, interesting. Okay, is this because of the null sort of thing to handle the null?
Yeah, because one, you're not allowed to have nulls in RxJava 2. But then it indicates to the consumer of the observable that you could possibly return a null, like a nothing, basically.
Right.
Whereas if you just have an observable of X, then you don't really know that like, the X may not exist when you request it. Like X may come into existence later, but it doesn't exist at the beginning, or maybe someone deletes it, it doesn't exist at the end. So that's one sort of wrapper that we'll commonly do these days.
And I shouldn't be using on-error to like handle that state, right?
No, like I said before, like on-error is really the equivalent of try-catch, and I think most people have figured out at this point that try-catch is a really bad way to like write code flow.
Yeah.
Like if you know your method will regularly return this exception, like maybe you shouldn't be using that. Maybe you should just have it return a sealed class that represents that exception. So
try-catch programming, like that's like the new thing these days.
Yeah, and I think it's also still abused in Java, but like not as badly as people abuse on-error in RxJava.
Yeah, I feel on-error is abused quite heavily.
Yep.
I'm probably guilty of it very early on as well.
I'm certainly still guilty of it, just trying to be a better person. And I want people to understand that if they've actually listened through to this whole thing, like I'm not some paragon of RxJava. Like I make mistakes all the time. I'm still constantly learning.
What?
I'm just trying to do my best. Just trying to strive for better code.
This changes everything.
RxJava, I say this consistently in all the teams that I'm part of. You feel the instant that you feel like you know something about RxJava is the instant that you realize you don't know that much at all. And it just continually gets worse and worse. You realize that every time you learn that little bit, the landscape's actually 10 times larger than what you realized.
Yeah. And I think it's just this overall attitude I've changed that I've had, where it's no longer just about the individual features of RxJava, because I think that's what appealed to me at first. Now I'm sort of more interested in the overall vision of like, what does reactive coding get you?
And just reminded me, like, speaking about mistakes, since this is like confession time, I remember like and you guys are gonna cringe listening to this. Two things that I did early on that was really, really bad. And like now I really apologize to my colleagues who had to like suffer through it, right? Is I remember with this whole Rx everything, I think I wrapped alert dialogues with Rx. So I had like an Rx dialogue component. My colleagues were not happy with that, and I was like, well, it's perfect, like, see, like it works with Rx, and they're like, yeah, but like the actual alert dialogue is like 20 times simpler than this nonsense that you've come up with. So that was like a hard learning experience. The other one that I did was like permissions. Like I had like this Rx permissions thing that I wrote because I was like, oh, this like makes perfect sense. And just again, like maybe there are better implementations of this, like where the API was nicer, but like for sure, my colleagues were not happy with like, the things that I came up with. Because again, like Rx, like you both have like rightly mentioned, is like a complex thing in itself. And like sometimes knowing when not to use Rx is like the most powerful use of Rx, right? I mean, like,
It is.
Yeah, you've got to use the right tools at the time. Like the permissions one's a real great example because you're integrating with the Android framework for that.
Right.
And the Android framework wasn't designed for it to be reactive.
Exactly.
So it becomes very weird, complicated problem to try to use Rx in those situations.
Oh, I know. All right, Dan. So like this is good. I like this has been like very interesting so far with like some of these topics. What are some resources? Because like I know you have like a pretty good blog.
I hope so. I've written two things recently that might be interesting to people, and one was so it's sort of a goal of mine for many years to write an introduction to functional reactive programming talk. And that's kind of funny to say now because like, but you've been doing this for so long. The problem that I saw in a lot of other talks was that they'd be like, look at this millions of features of functional reactive programming. Look at all these operators, and it would just blow right over people's heads.
Totally.
It's sort of like a thing to behold. And so I really tried to break it down into like its constituent pieces. What is functional reactive programming? Like the very basics of it. Something to get you started. And so I recently wrote up that talk as a blog post. I recommend people never write up talks. I'm never going to do it again. It takes so much more effort than you'd think.
I was going to ask that. Yeah, I was going to ask that. Yeah.
It's so much because with a talk, you just be like, and this is the slide, and I'll make up something when I'm on stage. When you write it, you have to think about every single word. It's just a nightmare.
The other the newer blog post that you wrote is also something that I think was amazing. And like, actually, kudos to you. Like, the way you wrote it was like fascinating, right? Like where like you came up, like you're the creator. Sometimes like, there's this saying, right? Your baby never looks ugly to you, right?
Yeah.
And so like, I did think it was like very mature of you to like come up with this blog post.
So yeah, it was a blog post about Rx lifecycle library written, which we referenced a little earlier, and basically why I'm stopping using it. Which sucks to say. Like I was sitting on that post for probably 3 or 4 months before I felt the guts to actually post it. Because it sucks to come out and be like, I've supported this thing for years, and now I don't really believe it anymore. So
I think that's important for folks to see that people who are active in the community could come out and say these things, because it's part of the life cycle of any software. It's software's never finished, it's just abandoned. And I'm not saying you're abandoning it, but it's just kind of that saying that goes along with it, that eventually we move on to different things. We realize what we were doing before may not have been the correct way to do something. So kudos to you for writing that and getting that out in public.
Yeah, and at the very least, my plea to library people would be, if you're not going to support it anymore, like, tell someone. If you're not going to maintain a library anymore. Because I ran into that recently where there was a library that had a bug in it. It was like, well, I wonder if he's ever going to look at it. I wonder if he's ever going to accept a pull request. And then we finally tracked him down and he said, nope. But then that was very helpful for us to know that like we should either go to a new library or should fork it or something like that.
No, I think, Dan, you've amazed me as you always have. Thank you again for coming on the show. Thank
you so much for having me again. It's always a pleasure.
We'll make sure to bring you on again once your thinking of Rx has changed. So version 3.0 of Dan Lew with RxJava will be coming in some time. Hopefully, much longer, but let's see.
Yep, 3 years from now, I'll come on and be like, it's all proactive coding now. Rx is old.
Yeah, that'll be a lot of fun. So Dan, if folks want to reach out to you and they want to ask you questions or they have like things that they want to ask, what is a good way? Like, what is your online presence these days?
Yeah, I think the best way would be to hit me up on Twitter. My Twitter handle is danlew42, so that's DANLEW42. And I've got an offer open right now, which is just to like, if people want to send me their call for papers or abstracts, I can help edit them.
Oh, nice.
Oh, wow.
This is partially selfish because I kind of want to do some research and write an article about like how to write these things. But also like, I just noticed that like people wanted help with this. So I originally thought I'd be like overburdened with editing calls for papers, but it turns out that like, no, I only get like one every few days, and that's not a big deal. I can definitely handle that.
This makes sense. And just like so our listeners understand, what exactly is a call for paper? What's a CFP?
Yeah, so like if you want to speak at a conference, there might be 100 speaking slots, but 200 people want to speak there. And so what you do is you send in a call for papers or an abstract, which is, just like a 2 or 3 paragraph summary of what your talk is going to be about. And from that, usually the conferences will judge which ones will make it in and which ones won't, because maybe they don't want like 5 different talks about the exact same topic. But a lot of the times I think that just people send in call for papers that probably just aren't well enough written, and they might have a really great idea, they might have a really cool thing that they want to talk about, but they're just not getting it accepted because they're not presenting that idea well in the abstract. So that's kind of what I want to help out with.
That would be very helpful. Thank you for this, Dan.
Yeah, no problem.
And Don, if people want to see what you're up to with all your Rx magic, what is a good way to do this?
The best way is going to be reach me on Twitter at Don Felker. And Kaushik, what if folks want to pepper you with some questions about RX and so forth? What's the best way to do that?
Also Twitter. Twitter is like a good way to reach all of us. I'm Kaushik Gopal on Twitter. We also have an email address, contact@fragmentedpodcast.com. That is a way to reach us. So yeah, if folks want to reach out, that would be a good way. Thank you all for listening. Dan, again, thank you so much for being here.
Thank you.
Thanks, Dan.
We will catch you folks in the next episode.
Have a good day.
Once again, we'd like to thank our episode sponsor, Kobaton, empowering mobile developers. If you're looking for a real device testing lab that allows you to test and identify issues faster, you want to check out Kobaton. Monthly plans start as low as $10 a month, and there's no annual commitment. Visit kobaton.com/fragmented to start your free 15-day trial and see for yourself.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.